Right, two important attributes of functions are extrema and zeros. So let's talk about those. Extrema are high points and low points. And before you hit an extreme value, a maximum or a minimum, you will increase up to it. Let's use a better pen there. You will increase up to it, or you will decrease away from it, right? So you're either increasing or decreasing as you move along the function. We say that a function is increasing, okay, if as x increases, f of x also increases. And f of x, remember, is describing your function value, your line. So as x gets bigger, f of x is also getting bigger. And this is important to note that it is going from left to right. So much depends on your view. All right, so we are always viewing the graph from left to right. Okay, a function is decreasing if as x increases, as x gets bigger, let's change color here, the function values are going down like this. All right, so f of x is decreasing. I would like to spell that right, decreasing. Okay. If you are looking at f of x, you might be asked, on what intervals is the function increasing? On which intervals is the function going up from left to right? So those intervals are this, this, and that's it. Those are the two increasing sections. So I'm going to write this in interval notation. I'm going to say I'm going from left to right from, I'm increasing. I'm going to write my interval from left to right. The first point where I start increasing is here at -8. And then I stop increasing right here at -4. Oops. Okay. So that's not the only place it's increasing. It also starts increasing again right here at -2. So I'm going to join these together with a union. -2, and then continues increasing up until here at 3. Okay. On which intervals is the function decreasing? Well, let's see. It's going down here and here. So we would say that it is decreasing from -4 to -2, and it stops decreasing, and then it continues decreasing at +3 until 10. Okay, note that these intervals are always written with the x values. Over which x values is the function increasing or decreasing? We are describing the domain over which that increasing or decreasing occurs. Okay, a local or a relative maximum, we say, is the highest value in the surrounding neighborhood. So like the mountaintop, right? Here is a maximum and here is a maximum. Okay, it's exactly what you think it might be. A local or relative minimum is the lowest value in the neighborhood. Okay, so a minimum is here, and then these endpoints are also minimums. Those are the lowest points around. Okay. So there are a couple places where we could write the coordinates of our local maximums and local minimums. We would say that this first local max is at -4. How high does that guy go? 1, 2, 3. -4, 3. And we would say one of our local minimums is at -2, -1. All right. We say that a function has an absolute maximum. I'm going to just, oh, I already wrote the word maximum for me. An absolute maximum at the highest point on the graph. So you decide which one of these relative maximums is your absolute maximum, okay? And that occurs right here at the point 3, 1, 2, 3, 4, 3, 4, okay? And we say that the maximum value of the function is 4. The maximum value right here is always your y, your function value. So you have a maximum located at the point 3, 4, but if I said what is the maximum value of this function, you would tell me 4. 4 is the highest that it goes. Okay? Similarly, we can do all of that again with minimums. I'm running out of colors here. Let's use red. With an absolute minimum, all right, at the lowest point on the graph, this can be either like a valley, or an endpoint. So in this case, it's an endpoint right there. The lowest point on the graph is located at 10, -2. And we say the minimum value of that function is just -2. Okay? Again, using the y for the value. Zeros of a function, so a zero of a function is an x value, okay? It's the x value wherever f of x equals 0. The zeros of a function are the same as the x coordinates of its x-intercepts. So I would write an x-intercept as, here's one right here. That x-intercept would be -1, 0, but I would say that the 0 of that function is -1. Okay, these are also sometimes called the roots of the function. So I have a 0 at -1. I have another 0 here at, let's call that, what, 2.5, -2.5. And I have another 0 here at -7. And I have another 0 here at +7. Okay, so this function has 4 zeros, and you just list the x values of those 4 zeros. Let's look at some practice problems. Okay, John runs at different speeds as part of his training program. All right, his heart rate is graphed below here, and we want to know on which interval is the target heart rate strictly increasing. That means only going up. So strictly means not going up and down or up and leveling off. Strictly increasing and then strictly decreasing. So between 0 and 30 minutes, let's see what John's heart is up to. Between 0 and 30 minutes, I go up, I stay flat, and I don't decrease at all. So that's not an option. Between 40 and 60 minutes, so 40, I go up only, and then I go down only. That's promising. Let's double check the others. Between 50 and 65 minutes, erase what I've done here. Between 50 and 65, I go down. Oops, I go, stop that. I go down, and then I go up. So I'm strictly decreasing and then strictly increasing. So it's not C because it's doing it backwards. And then between, let's erase that. Between 70 and 90 minutes, it's 70, I'm not doing, oh, I'm here, and then my heart rate jumps, and then it flattens out again. Okay, so I would say that there's no decreasing, and it's not strictly increasing. So the answer to this one would be B. Okay. The complete graph of the function f is shown in the xy plane above. For what value of x is the value of f of x at its minimum? So I would need to find two things. I need to find where the minimum is and then the x value that goes with that minimum. So the minimum is they're talking now absolute minimum. If f of x is at its minimum, that's implying that there's only one, so we're talking about that absolute minimum. And while the coordinates of that absolute minimum are 1, 2, 3, -3, -2, okay, they are asking for the value of x. Make sure you're reading the problem. So the value of x, where it's at its minimum, is a -3. We say that's like the location of the minimum. If it asked what the minimum value was, that's when you would look at this -2. But they didn't ask that, so we're not going to write that. We're going to answer this question with a -3.